Okay, so here we're working on truth tables. So in order for you to be able to do truth tables, you have to understand the outcomes for each type of compound statement. So truth tables are just there to give us the truth value of some compound statements. Okay, just the abstraction of it, essentially. So first we have all these different types of compounds. The first thing we have the negation. The negation is not necessarily a compound connective because you just negate a simple statement. You don't negate between two statements. Okay, so essentially what happens is you should read over your PowerPoints, read over your notes, read over the book. But essentially what you have is you have these other ones, which conjunction, disjunction, conditional, biconditional. These are connectives. These connect simple statements together. The negation, you negate a simple statement, or you can negate the entire compound. Okay, so the tilde, this is the symbol here. This little symbol here is the not. Okay, and the word to represent the symbol is the word not. So basically you have the original setup. So a simple statement, P, negate, you only negate the simple statement in theory. So your options are the statement could be true or the statement could be false. So if it's not P, the not of a true is a false. The not of a false is a true. So the negation essentially is just changing any true statement to a false statement and changing any false statement to a true statement. Okay. Then we have the conjunction. The symbol here is like an upside down V. It's like the boomerang. All right. And the word for the conjunction is the word and. P and Q. P and Q. So true and true always yields you a true outcome. True and false always yields false. So on the conjunction, everything is false except for true and true. All right. So in order for the conjunction to come out as a true statement, compound statement, everything has to be true. All right. Then we have the disjunction. The symbol for disjunction is the V. All right. So upside down. So, and if you can connect it with what you had in chapter 2, the intersection, which means and, is the upside down U. Right. The union is upright, just like the V, and it represents the word or. So your words and your vocabulary carry through. So if you learn it in the first chapter, you're just going to build. You're just evolving. So here we have P, Q, P or Q. So your first two columns are always the same. Your P column is always two trues, two falses. Your Q is alternating, true, false, true, false. So true or true is always true. True or false is always true. False or true is always true. False or false is false. So these tables are like your multiplication timetables. So when you learn your timetables, those are always the answers whenever you come across that set of values. So when you learn 3 times 4 is 12, you can multiply any numbers that may contain a 3 and a 4. So 34 times 3. Well, 4 times 3 we know is 12, so you would know how to multiply that problem. That's essentially what's going on here. Essentially what's going on here is we are identifying our outcome so that no matter what truth table we have, no matter what combination we have, we can always know the outcome, whether it be true or false, based on the connective in the compound statement. Then we have the conditional. So the conditional is if then, okay? So when we're doing the conditional, we have the arrow, if true, then true. That's how you read that. If P, then Q. So this comes out true. So essentially for the conditional, the only one that comes out false is when the second one, the antecedent, comes out as false. Okay, so the second, whatever's behind the arrow, basically almost your conclusion, comes out as false, then your answer for the conditional is going to be false and everything else comes out true. Then for the biconditional, if and only if. So for the biconditional, it's only true when both P and Q are the same. So if true, if and only if true is true, false, if and only if false is also true. Everything else in between is going to be false. And so what you have to do is you have to learn and memorize these essential basic truth tables so that when you have a truth table problem, you are able to identify all outcomes. So move forward to another video for a further example.